with that, we'll get started. This presentation is why automate. So, it's not switching slides here. Here we go. So the agenda of this presentation, I want to cover four main topics: the current state of automation, the benefits of automation, what can be automated in your facility, and how to start calculating an ROI. So with this, we can get rolling into the current state of automation, and this is more of a global look at automation. So not just regionally, not just in the United States, but globally. So in 2019 was a good year for automation in North America. It was up just about 1.5% over 2018, and in the US alone, we installed 33,300 arms. This year, it's obviously been tough. Capital spending amongst the COVID has declined quite a bit. So through August, it was approaching 20% off as compared to 2019. But the big thing here to look at is how the US stacks up against other countries. So we installed 33,000 arms, and we're number 3 in the world. Japan was close to 50,000 arms, right? But China is 140,000 arms. And so it's quite a drastic difference there. China actually put more arms in than the next 5 on the list combined. So that's it's a little bit strange, but you kind of think back on why some of that is happening. 2.7 million robots currently around the world are working in factories, so that's a pretty good number. Can get a lot better. So if we look at how many robots were installed, the next thing I want to show you here is how does that stack up? There's an interesting stat here. So if you look at Singapore or even South Korea, they have close to 10% of their manufacturing workforce is robots. So what this chart shows is number of robots installed per 10,000 employees. So if you look at Singapore, they're at 918 robots per 10,000 employees. And if you look at this, the US has actually got a higher robot density in manufacturing than China does. China also has a lot of people and a lot of manufacturing, right? There was a lot of manufacturing moved over there for consumer items, and so there's a lot of factories, a lot of factory workers. They're looking to fix that. So it's kind of interesting when you look at robot density, how Singapore and South Korea are just so far in front of the rest of the world as far as robots in manufacturing. So essentially, what's going on in China is over the years here, since they've gotten so much manufacturing, their economy is growing, right? The quality of life's growing, and so is the cost of labor associated with that, right? And because of that, over the last 5 years or so, we've seen a lot of reshoring. And the reshoring is happening because automation is getting to a point where it's cheap enough now that if you automate in the US, you can very easily compete with the lower labor costs in China. Some of the downfalls with China and offshoring of manufacturing is you got to do large quantities, right? You got to fill a whole shipping container and get it shipped across the ocean. So you have a lot of inventory. You lose a lot of control of your process and your quality. And I think a lot of companies found out they lose control of their proprietary information. And so being able to automate in the US and win back some of this manufacturing work is really a trend we're seeing right now. So, but China's realizing that, wait a second, everybody else is automating. We're losing a lot of this manufacturing work. We need to start automating, or we're going to be making nothing in the near future. And that is why they are buying robots as quick as they can be produced. For example, you saw that slide, there was 33,000 installed in in the US, there was one company in China that actually had purchased 39,000 arms in one shot. So, I mean, the government is highly invested in this. Obviously, they're very, very tied into business in China with the way that's set up over there. And so they see this as the future of being able to keep the economy going and manufacturing going. And so they are automating as quickly as they can to help keep up with North America and Europe and others. But so we are somewhat in a race to automate and keep our systems efficient and flowing and retaining manufacturing work. So the next part I want to talk about here is the benefits of automation. We're going to go through a few different things here, but some of the benefits of automating in your facility consist of part consistency, right? So you take some of the human element out of it. We all have good days and bad days, and part quality can vary depending on good days and bad days. Automation can also help reduce a lot of rework with parts, right? Because of the consistency. And so rework can go down, scrapping of parts goes down, and there's quite a bit of cost associated with that in certain processes. So automating it and getting it very fine-tuned can really, really help you on the part consistency side. One of the biggest things, this year shook things up a little bit, but the problem is still there underlying is there's a huge labor shortage, right? Middle of 2019, I mean, there was the unemployment rate was low enough that basically nobody's looking for work anymore at that point. And so some of the biggest hindrances to a company growing or getting to the next level is the fact that they couldn't hire enough people to even produce what's needed to grow the company. And so filling in gaps in the labor shortage with automation is a big deal. You can put a robot in an area that's maybe really redundant, very easy, and you can utilize that employee in a different part of the facility. You're not actually replacing an employee, you're relocating an employee in your facility and putting them in an area where it's much more value added to your process. Safety is a big concern in most facilities, and obviously I think rules as years go by are going to get more and more and more stringent. You know, you can put robots into places where it's dangerous, repetitive, ergonomics are horrible, heavy lifting, right? They have robots now that lift less than a pound all the way up to 5,000 pounds fully loaded. So kind of anywhere in between there, you can find a robot arm to handle parts. And so this can drastically increase the safety of your facility getting robots into certain areas. Some more benefits are increased throughput. It's kind of the tortoise and the hare, but if you envision even slowing your part process down just a little bit, so imagine it takes you a minute to weld a part. Even if the robot, for example, were to take a minute and a half or a minute and 45 seconds, but it runs part after part after part, no breaks, just keeps going. At the end of the day, you actually find that the robot's producing more parts. We all know that you probably produce a lot more in the morning when everybody's fresh doing things, but as the day drags on, people are, especially if it's rigorous work or that they'll wear out over time, and you slowly kind of your process slows down by the end of the day. That can be one of the benefits of automation. It completely runs the same pace nonstop. There's also abilities to be able to queue up large amounts of work, so that imagine all you do is run a 1 8-hour shift in your operation. You might be able to queue up 2, 3, 4, 5 hours of extra work for the robot system. And when you leave after your 8-hour shift, you shut the lights off, and when you come in the morning, you have all that extra work completed. Not all operations can be set up like that, but there's a lot that can. So you can extend how long you're actually producing parts per day. Optimizing part flow is another big area. So I think we could all probably sit back and think about how many times a part actually gets touched from the start of its production to the end of its production. And some of the touches are needed, some of them are not. So if you envision a process that you have a laser cutter and it's cutting out sheets of material, and so it cuts all these parts out and it gets set down, and an operator is sorting those parts afterwards onto a pallet, right? And then that pallet is picked up and moved, maybe even to another whole section of the plant, depending on the size of your facility, to be run through a press brake, right? And so then an operator picks the part up, bends all the parts, and more than likely sets them back down on a pallet to again be picked up and maybe brought to another completely different part of the facility where you're welding parts, right? And so it goes into that process, and all the parts been moved around the facility 2 or 3 times, and it's been handled at all 3 of those steps throughout the way. And then from the welding, you know, it could even go back onto pallets again into an area where it needs to get sorted, assembled, put in packages and whatnot. All along that entire time it takes you to pick up those parts on the pallet, move it to the next station, pick it from the pallet and put it into a fixture or onto a press brake, adds 0 quality or value to your part. All it really does is raises the cost. So with automation, there's ways of being able to kind of focus some of those larger areas and put them all into one system. So imagine what I like to call a focused factory on your floor, where you have a high enough volume that there's a laser cutter that flows right into a press tending system that flows right into a welding system, and from laser cutter to just before it's ready for maybe powder coat, nobody touched it, right? That's it. That can be a huge deal as far as removing labor costs and non-value added touches on your part. Not only that, it can reduce fork truck traffic on floors, right? Fork truck traffic is, it's by nature not all that safe, right? There's a lot of safety things that are done to keep people safe, but at the end of the day, it's like cars on a road, right? Eventually there's going to be some crashes or some stuff that happens, and whether it's humans that get hurt or equipment that gets damaged, reducing fork truck traffic can be a big benefit as well. Floor space savings. This one is very dependent on applications, but there are times that you can reduce your footprint on your factory floor by upwards of 50%. Just by automating it, right? As you're doing processes by hand, we need enough room. We need to be able to move around. We need to be able to handle parts safely with jib cranes and different things. That all requires space. So if you can really narrow this process down and put the robot in as small of box as possible, that can add a lot of floor space. And most of us know floor space is a pretty valuable commodity in most instances. So moving on from some of the high level benefits of automation, I'm going to give you a high level now of what can be automated on your factory floor. There's a myriad of different processes. So starting off with their assembly processes. So taking small parts and putting them together, right? Part after part after part after part. These systems can be more high end. They're more expensive because there's a lot of dexterity that goes into these systems, but they also can be very valuable because what comes with a lot of these assembly systems is in-process quality, right? So you can use vision systems or other type of sensors to not allow you to assemble something incorrectly, right? Again, as you or I assemble something, there's a chance that we could do something wrong. And automating some of those processes takes some of that quality control or quality assurance and puts it right into the process. So there's a myriad of different things you can do in that world. Floating next into welding, plasma cutting. This is a big one that's out there. Welding's been a very, very established automation application type for many, many years around the country. This is being used heavily in the auto industry. I know we talked about that a little bit earlier, but welding is a big one that can really, really improve weld quality, right? Welding is very dependent on the operator having a good day and paying attention and making sure they're putting down a good weld. The robot, once programmed and brought in, parts can be brought in, they can be heavy, it can be spun, turned, flipped, moved into position very easily, which in a lot of times can reduce how much time it takes to create a part. So if you imagine you have a large part that needs to be rolled over 5 times, and you need a welder to use a jib crane and a hoist to flip this thing over, in an automated system, you can literally set that part down and spin it with a programmable servo motor that the robot controls. And so that you always ensure that your weld is in the correct position, but also a very, very consistent weld quality. The interesting thing about robotic welders versus your hand welder, and they're bringing some of this into the hand welding and it's being utilized, is the robotic welders is a closed loop system. So if you're telling the welder, I want 25 volts coming out of this gun during this entire weld, if it senses it's either going down or going up too much, it'll automatically adjust on the fly. So what it's really doing is putting as consistent heat input into that weld as possible. Plasma cutting can be automated as well. There's a lot of benefits to that. So you can automate flat sheet plasma cutting, as well as beam and tube and pipe and all kinds of different things there. So one of the new things that's come into the market, and I'm sure you've all kind of heard the term the collaborative robot or cobot. These robots are unique. The one I'm showing here is actually a welding application, but you can use it for a lot of different applications outside of that. The cobot itself is a robot that you can work next to. So you're going to see in some of these slides, these robots move very quickly, handle very high payloads. So there's a lot of safety involved around them, right? They're fenced in, so you can't accidentally walk in front of it. Cobots you can work next to. They are set up, they have high-end sensors in the arms that if it bumps into you, it stops, and they don't exert a lot of force. Cobots are a little bit slower as far as top speed, because once you get too fast, that bump isn't so much of a bump anymore. So this is a big thing that's coming into the industry, being able to do very simple welds. The cool thing about these cobots versus the standard industrial robot is you can grab this robot with your hand, move it into position, teach the start point of a weld, move it to the next position by hand to teach the end point, and then hit start, and that robot will play back exactly what you just did by hand. So it's very, very easy to program and can be used in more of the job shop environment, which has always been the tougher spot to automate, right? Automation, you always think high volume, high speed, very low part number mix. These collaborative robots that are hitting the industry now are kind of breaking into the high part mix, low volume world, which allows a lot of people that historically haven't been able to automate things in the past to be able to utilize automation. So you imagine this robot, you have an operator runs over there, you put a part on there, you teach a weld, and maybe you only weld 50 of them, but it may have taken him 10 minutes to program the weld, where on a industrial system, it can take much more time than that. So after that, you can, after that batch is done, you can put another part on there, program it very quickly, and you're off and running again, and not having to add a whole bunch of welders to your mix to do it. So pretty cool new technology hitting the market. The next one on here is palletizing. So end of line palletizing. You envision a box running down to the end of the line and an operator picking it up and stacking pallets all day long. I'm sure there's a lot of it out there, and I'm sure some of you are familiar with it. This is a very good area to automate. Not only does it save safety ergonomically from lifting boxes all day long, but the cool thing is you can put multiple zones on this. So for example, the system you're looking at here actually has 6 different pallet locations. They'll run up to 5 different part numbers. at a time on the same inbound. And it's as simple as a barcode scanner. Reads the barcode on the box, and the robot knows which stack it needs to go on. The other neat thing about this system here is phase 2 of this is actually to stack these boxes on a pallet, but raised up in the air about 4 feet. And what's going to happen in the future is an automated guided vehicle, so an AGV, so a robot forklift, essentially, is going to come over once the pallet is full, pick it up and bring it to the next area and set down an empty pallet. So this is automating these little pieces, helps link processes together and makes everything more consistent, so that maybe you can bring in automated fork truck traffic into your facility. Material handling, this is a big one, and machine tending. So you envision all the CNC machines out there in machine shops where you have operators lifting parts off of pallets, loading a machine, hitting the start button, right? This is a process that can be automated fairly easily, replacing the operator with a robot. The biggest bang for your buck on these is the heavier the parts get. So there's a lot of machine tools out there that are loaded with a jib crane or some sort of hoisting device because parts are too heavy. The robot can easily swing over to a pallet, use vision to find the part, pick the part up and load the machine. And they are completely Ethernet connected now to most of the new machine tools. And so the machine and the robot are talking, and once loaded, it can tell the machine start. And the machine can run through its process, open its door and tell the robot, I'm done, come pick it up, and continue that process. So this example here on the screen, they're actually picking a part up, loading a laser marker, and then putting it on an outbound conveyor. So the small part that's on the screen here used to be on a pallet, picked up by an operator, set in this door you can see through here, and hit start, and then picked up and placed back on a pallet. What they did is they actually tied these conveyors that you see going in and out of this system to the process that's upstream from this and downstream. So now the process that it comes from, which is some machining and assembly, flows down the one conveyor, it gets marked, and then it flows back out to go into the next assembly process. So very streamlined again. Material removal processes. So, and what material removal processes are is polishing, grinding, deburring, maybe some cutting. And so this system here actually used a router to cut some aluminum panels for this company. And these processes can be automated. There's a lot of homework and a lot of work that goes into a material removal process. Mainly because if you think of welding, there's a pretty strong accepted spec in the welding world that a 1/4 inch fillet needs to be fall within this spec. When you get into the material removal process and when you're deburring, a lot of times there's no set spec that says it needs to be X, Y, and Z that's kind of accepted by everybody in manufacturing. And so there can be a lot of testing and that is involved with this, and also trying to figure out what kind of media is correct, maybe for cutting, polishing, or grinding. These processes can be hugely beneficial, but they do take a little bit longer and tend to be on the more expensive side, but can have a huge return in the end if the right steps are gone through. So I spoke a little bit about return. I want to give you guys some things to think about as far as where do you start? How do you calculate an ROI? What are the things I should look at? Obviously, some of the easiest things and some of the things that come to the forefront of everybody's minds is what kind of labor savings on this process, right? So you're going to want to calculate labor savings. A lot of these robots can run unattended for long periods of time. And so what you need to figure out is how, if I'm taking a welder away from this process and putting them into a more advanced weld that's tougher for for a robot to do, and I'm using an operator to just make sure that this machine is being run and being attended to and continues to have work to do. What labor savings are involved with that? Is there a lower cost to the operator versus the welder? And in a lot of instances there is. So that really helps out. How much time is that operator spending at that one system during a shift, right? Do we have the automation set up where the operator might be able to tend 2 or 3 systems throughout the day, depending on how long the system can run unattended? So you're going to really want to dive into some direct labor costs. Productivity gains. And so this is a big one. We talked about it a little bit earlier with some of the benefits is your increased throughput. What are we looking at? And depending on what your forecast is in sales and what you're doing there, what you don't want to do is buy a robot system that only does what you're doing today. If you're planning to grow, you want to look at this and say, I want a system that's able to handle 30% more, 25% more than we're doing today, so that you give yourself some room to grow without the added investment right away. So you're going to want to look at how much more productivity are you getting out of this system versus doing it manually, right? This can be a myriad of different things, right? It can be labor costs. It can be the cost at the times that the plant is open and running. So increased productivity can also come from what I spoke about a little earlier is, does this process have the ability to run 3 hours after everybody goes home, right? And so those are things that you're going to want to look into. And now you're maybe doing 11 hours of work for the cost of 8 hours of labor, right? So these are the things you're going to want to document. Safety costs. This one can be a little tougher, but if you're not having a welder standing right there, do you have the cost of a weld hood and weld gloves and weld coats and all of that kind of stuff that was directly related to this part before? Is that being eliminated? Is this process ergonomically not great and you've had workman comp issues associated with it, right? Those costs can be put into your ROI as well. Scrap costs. This one is tracked very well and very poorly in different facilities, right? Some people are tracking, or some manufacturers are tracking right down to the last penny on what's scrap and rework costing our facility. And some really aren't doing much with it. This would be one that I would really encourage people to look deep into if you're thinking about automation, is try to get to some of those costs. How much are we actually scrapping? How much time are we actually spending reworking it during our current process? That stuff's expensive. That's, at times you could be putting double the labor into one part just to get it through because something got screwed up and it needs to be reworked. So I would encourage everybody to look into some of those areas because there can be bigger dollars in there than you think. Not everybody deals with this, but some people do. Manufacturers have to deal with their customer rejecting parts because of quality, right? And if you could increase your quality by 30%, meaning you're reducing your customer reject cost by 30%, what is that number? And can you sustain that over time? So these are all items that you're really going to want to look for and put down on paper so that you can decide, does this system make sense for me? There's a bunch of different calculators out there. I'm showing an example of one on the screen of a $225,000 system. Currently, their production runs 2 shifts a day, 5 days a week for 50 weeks a year, right? There's some small electrical costs per hour for the robot and an annual labor cost fully burdened of a welder, let's say, is $60,000 a year. That's probably a pretty conservative number. It's probably tough to get to that in the weld world today. But if you can set up a process that removes 75% of that individual's labor and gets you an extra 25% of throughput and a random $1,000 of extra savings per year for scrap, rework, and ergonomics, that number is probably pretty conservative as well. This system right here based on those couple metrics as a 2-year return on investment. And that's huge, because I know there's a lot of us in this room that if we could give a financial guy $100,000 and he said in 2 years, you'll still have what you gave me, and also returned another $100,000 in 2 years, we probably wouldn't be on this webinar today, because we'd just be doing that instead of working. So, I mean, these are huge returns, and these systems can run, depending on what they're doing, anywhere from 10 to 15 years. In my past life, I've had a system that was 28 years old, still running. And so again, it was kind of funny that we segued from the Japanese automaker. A lot of these robots are Japanese made, and they're very high quality on the mechanical side. So with that, I'll open the floor to any questions.